Slava Ukraini. Thank you for hosting me in this conference, State of Java. First of all, a small introduction of myself. My name is José Garcia. I am an expert software engineer at Singular with more or less 17, 18 years in this mess. I am leader of the USQ initiative, where we hosted some open source products like CalloGene and these multi-API tools. And I am the master slave of my two cats. So, what can you expect from this conference? Just another way to do the same, another tooling, another way of thinking? Who knows? Let's gonna see what I can show you. First of all, long story short. Once upon a time, the systems were a unique piece of software, a big, huge amount of code and iron that are running all the business logic. They are durable, they are fast, but they contain all the chaos in just one small place. The bad things of this approach, they were not easily scalability, the high and expensive evolution, and maintenance is quite complex. The time was passing, and the world became more connected. The old system started struggling with an increasing number of requests. So the world is going more digitalized. So this system requested more speed, requested more data, more users want to use our software. So escalation became a thing, the next challenge. The old approach was, okay, I have a server with my monolith thing, I need more monoliths so they can connect together, new problems start to appear in this kind of orchestration, and the chaos appear. The chaos. The process flows became communication channels, where once we have calls to single APIs or service, just become communication between different services. The service promoted to independent software artifacts. So when we start one big enough piece of software, we start several small ones. So the problems start to appear. How this piece of software can communicate, what data need to be shared, what structure this data will have, how the data will be stored in databases, etc., etc. So we have the first discovery. The API definition appear Open API, Async API, Ramble API, Asterisk API. There are several of them that start coming on over. So helping documentation all the data. The documentation became the new thing. All the APIs want to be fully documented with all the options, parameters, data structure, and this documentation was shared all over the world so everyone can connect with us using this API. So we got answers to what I need to call, what data I need to send, how I should structure the data in order to understand each other, and what are the endpoints with the REST verbs I should use in order to communicate with the systems. But this comes with more chaos. The API definition was service-centered, meaning that I have a service, I have the API, you have another service, you have your own API, but there is no common API in between us. So continuous changes in the APIs bring more case to the equation. More chaos, last time changes, breaking changes with previous definitions. Teams start to wait to other teams to complete the piece of software in order to start using this, start communicating with them. Then came the second discovery, a new paradigm born, the ApiFirst. What is the ApiFirst? It's a defensive way to talk each other, like a human and a monkey. They start communicating with sign symbols, color. So they structure a message system that is easy to read and understand. And then the focus move from implementation into what need to be communicated. The API first tell us that first we need to define the API, all the values, all the data structure, so we can easily communicate between us. So once this contract is already set, we start working in the full implementation. But something was still missing. The API definition still was not enough. Why? We miss a way to validate this API between teams. Still need to wait for the other one to deploy because they need a set of data, staffs to make the test, to verify that all the communication is fully aware, and there is no full visibility between, let's say, a system with 20 microservices. You cannot see what's going on in all between all of them. So it's like a bit of chaos here. So about in the 17th appeared a new paradigm, that is the contract testing. What is the contract testing? There are different definitions about, but all of them has a set of common points. There are two main actors, consumers and producers. They are based on the schema of the data. They define some bindings for the field, so you can verify that the data is sent into one field has match some constraints, like the size of a string, the range, some integers, the top value, the minimum value. They are multiplied of X number, etc., etc. But the most important was an agreement of minimum. So the contract defined what is the minimum set of fields that should appear in this schema in order to be used by the consumer, or the consumer sent to the producer. There are two big players in this world, as far as I know. You have the Pact and we have a Spring Cloud contract. This one is my favorite, and I will make a demo with using this. So, what is this for? The main objective of the contract is guarantee the correctness of the measures, allow us to test the property bindings, allow us to test both actors, consumer and producers, and generate validation for the producer and generate the stat for testing. It provides independence between the teams to develop. So once I have defined my contracts, I just send them to the different actors, and they can start working with their own times, with their own sprints. In the meantime, they are still fulfilling the contract. The communication between this piece of software should be guaranteed, not say 100%, but maybe 85, 90% sometimes. So it's quite good. Let's see some examples about the contract specification. Here we have a model of the REST contract. So as you can see, there are two different sections, the request here and the response here. Here in the request, I define the method that I am testing, that I'm building this contract, the URL that is attached to this specific contract, and the body of the request I am fulfilling, and the headers. Down here, we have the response for this contract, the status for making a put for this specific URL with this specific data in the body should return an OK status and this specific body, okay, with this specific header. What it will produce? It will produce a test for the producer where this URL will be invoked with this specific method and sending as parameter this specific body, okay? And the producer will send a response. This response will be validated following rules based on this body. What is expected for the consumer? The consumer, once it produces an put call to this URL with a specific method, will obtain a stuff, a fake object or a mock object with those specific values specified here. So both of them can start working and testing the behavior without now each other has completed the development, okay? More or less, what we have here is some kind of human-readable specification. You can define here as Groovy, as you can see. We can have a YAML, or, well, not totally human-readable, but you can also use Java. I think there is some implementation for Kotlin, etc. So, as I said before, specification will be triggered by the specific REST method. The structure is involved, and we are fully language independent. What means that based on this contract, I can test the consumer or the producer made in different languages. There is no attachment between this test and the language used for produce the software. So we can have consumer made in Node for the front end and the backend made in Java, and this is absolutely transparent for the contract testing. Here we have an example for a contract specification for an event architecture. So we still have two different settings, the input and the output. The input, you will introduce which message you will receive if you are the producer, or which message you will send if you are the consumer. And there are three different ways of trigger. The trigger produce an output message, we can specify here. An input message produce output message, this example that we have here, or an input message without an output. So we are working with events, we have these three different possibilities or use cases, okay? So as you can see here, we have two places where we define where the message came from, the channel, and where it sent the message. We have here specification for the message body, okay? So we have an amount, a late updated date, a name, an ID, etc. So when the producer, where one of the elements in this communication receive the message in order to trigger some logic, they will receive this subject specified here with those values, and it should produce an event to this specific channel with this specific body. So it will generate a test that verify that this message will be produced with this specific, let's say, schema. You can produce, your software can produce more fields here, yes, because this is a contract of minimums, and the body that you will receive in the real world can have more fields than here, yes, you can, because this is a contract of minimums. So those are the minimum fields that is mandatory to send or to receive, okay? So how we can do all this magic in the real world? Actually, we have some official tools. We have an open API generator that generates the code. We have an async API generator to generate the sync API definition, code based on. But you still need to generate the contract by yourself. There are other tools like the SyncWave SDK that generates the full service based on both specifications, but you still need to define some kind of contract testing for that. But what we made in Singular is those multi-API tools. We have a plugin for Maven and Gradle that understand OpenAPI and Async API and can generate the skeleton for you to code based on those APIs. We don't generate the full service. We don't generate the interfaces and the skeleton part for receive or produce message, for receive REST calls and make calls to another third-party service. And we also have a SCC multi-IP converter, so we can read these specifications and generate a contract test. So, meaning that I can generate for you this test with the values specified in the API just with one single tool. So based on the API first approach, you define the API, and with this tooling, you can start generating the code for both actors and the contract testing for those both actors. That's okay? So, do you want to see it working? Let's go to the show time. So, let's gonna see a bit demo here. This is a small pet project that they have for testing events. So here I have an async API definition where I specify the servers that I will use for development, for staging, and my environment for production. Those are fakes, of course. And here I define in my channels 3 different channels where I can publish or subscribe for events. If we were talking about Open API, instead of channels, I will have the URL for paths. Instead of publish or subscribe, I will have my get, my put, my post. This example, I don't have a REST API, but the how to work is the same. There is no difference between. The operation ID will represent the number of the functions that will where our auto-generated code will be host. So an account emitter will appear somewhere in the code, and a stop movement function will appear somewhere in the code. So I can implement my logic for where to handle the message that I will receive. And here I will have a function where I can send the payload for the message I want to emit or publish to the system. About the structure of the message, okay, about the structure of the data are handled in those files here. So here I will have my account event object with those properties. So the structure is easy. I just define that it's a type object with some properties. These properties will be those ones named here in the list and the type of the field specified. And if I have some restrictions, I will introduce the restrictions here. So here also the format, so this string will be treated as a datetime. About the movement, and we have also defining my type object here with some properties, the type of the field, and I introduce here a new concept that is an example. This example means that when I generate my tests, my contract tests, I will generate an stuff with this value. Same happened here. I have an account number that is defined as a string. Has the binding of this specific URL. And here I will have a specific value. Let's say I want this to match the pattern here. There is no sense I have an example that doesn't match the pattern. If I run the test in this case, it will fail. We'll see later. About this field here is defined as a string, but with an enum tag. So meaning that we will treat it as an enumeration with those specific values. So in my example, I choose one of those. And regarding numbers, I have here a type number, which is treated as a float. And I have an example here about the flow number that will appear in my test. So once I have defined my different schemas and my API, I just need to add it here in my POM or in the graded build. In this case, I'm using a Maven project. So you can see here down, I have the multi-API Maven plugin, okay, where I'm specificating, that is an async API generation. So passing the file here and specifying which channels I want to consume and which channels I want to produce with the API package and the model package. So this can be different or this can be the same. I can, let's say, not fulfill the API. So if I have a third-party API that is defining another service that is publishing here, I can define here that I am only consuming the value produced. In this case, this is my own API, so I will specify here how I want to produce the code. But if you're talking about a common API that is shared between two services, the other service will define that consuming the account emitter and producing for the store moment of the store account or one of them. These configurations will be specified here. You have more information in our GitHub. I share later the link and with the complete README or documentation for that. And regarding the contract testing, as I told before, I am using the Spring Cloud contract, okay, the Maven plugin. So I need to add my converted as a dependency, meaning that I will go to this folder where the APIs are. I will get all the YAML APIs and will convert it into the contract I will show you before. So once I have these two plugins configured, let me close here. Oh, let me close. Okay, you can see that these two plugins here configured. I just need to create or execute the install, so the code will be generated. Also, the test should be run. Just give it a few seconds. You can grab a coffee or a Coke or whatever you want. Okay, some tests are failing. Oh, this is something that I will show you later. Let me fix that here. So for later running, whatever. So here, the generated sources, you will have the model, the listener, and the emitter folders. As you can see here, we have a subscriber configuration. So two bins will be generated with consumers that will be attached to the channels that I have defined in the API file. These two interfaces are also created here, and those interfaces will contain the definition of the method that will consume the event that is expected to receive. In this case, the bank movement, and in this case, the bank account event. So this class will provide the necessary methods in order to make the entry point for events, external events into my system, okay? Here I have the events defined. You can see all the properties that will appear here and in the movement, with also the enum with all the necessary methods are the same I have specified here in the bank movement. So they have the bank account. I have here just use the movement. So the fields that I have here specified are the same I have here defined. The enum that I have here are generated with this specific name, and I have here the public enum type with those values I specify in this enum tag. Okay. Same happen with the amount is defined as a float, so a float type will be used. Regarding the dates, they are defined as a string, so the strings are used for contain this data. About the accounts, you can see it's the same as before. All the fields defined here are created in this DTO. In this case, the bank account even. If I want to change the name and add the DTO tag, I just need to come here and I have there is a tag. Let's see the autocomplete thing. The suggestions. You can have here a tag for the DTO, and will appear the postfix model, and you will have you can put the DTO. So the DTO will be generated and added to the name of the classes. Also, you can have a prefix, so you can absolutely customize the name of the classes that you are generating. Okay. About what I can do with those interfaces. Here I have the producer. So this component, we generate a producer that will produce a message into this account that is defined as I showed you before, right here in the account emitter. We don't create configuration because this is more particularly for every project, but we provide the necessary steps just in between configuration and the code, so you can start building all your service around that. So those interfaces here are implemented here in my event listener. So here is all the logic that I need to process all the data that is introducing here in the back account through the interface and through the subscriber here, okay? And here I can call my services, I can call my account counters for metrics, I can use load information in the console, do whatever I want. There is no limit. So once I have implemented this interface, all my logic will be here, okay? Same happen with the movement. I have here the interface for the store movement, and I can receive all the events and save them, do some incrementations and all the stuff. What about the producer? The producer is defined, is used as a bean. So in this component, I can have all my model entities. So I can use some mapper to convert it into the event that they will send, and it will be sent through the producer account emitter, that is this stream bridge producer that I created with my code. So the first part of this conference was about ApiFirst and ApiFirst implementation code with tooling. So this is the first part, okay? What about the second one, the contracts? So now I can have the API, I can start working in my logic, but I also need to test that what they are working is correct. So that's the point of the contracts. So for that, what we are generating is here in this contracts folder. I have this event class. This event class extends the event base. And this event base is my own implementation here, which contains a couple of things. So first of all is the Spring Cloud contract configuration, the auto-configure annotation for message verifier, some import auto-configuration for testing the channel binder so I can intercept the message, some test instance annotation, etc. The thing is, in this class, I will create all the mocks or just use the proper service attached going to a database in order to run all the tests. So I can mock the things or I can use the real ones if I have them implemented. Also, I can have some captors, some argument captors. If I don't want to check the database once I save the data and receive it, I can use argument captors to capture in somewhere in the middle of my logic and then do some testing about. But what I need to auto-wire it is the back account emitter. This is the real one, so I can produce real messages into the channels, but the interceptor will catch them and then we run all the validation that we show you in the next moments. So this function here contains the necessary logic for emit a message. So we have this entity. It will run into the account emitter. As you see before the account emitter here, we have some mapping function that convert into a bank account event, okay? And then we send to the producer, and the producer will go to this stream bridge, and then we produce the message in this channel. So far to now, we are just creating a message from here to somewhere else. What happened with this method? This method is called with this one, okay? So we have a validate account emitter test that will be run as a normal JUnit test. This method will be executed. This method, as the same I have here, will produce a message. In this piece of code, I will intercept the message into this account, into this channel, will be validated against the account emitter YAML that is test generated before for the code. First of all, it will be asserted that it's not a null, so it's something here in the response. And then the response will be parsed as a string. Why as a string? Because as you can see here, we will go field by field, executing some regex validations. Where those regex validations came from? Well, if you let me go back just a bit later, here I have my bank account definition. Okay, my account definition, I defined the ID field is a type string. So I have an ID field that is a string, but the content of this field should be a string. Normal string with letters and numbers, and that is. If I want something special, I just can use a pattern here for regex. This is the pattern I can see here for the account number. So my account number is a string. This string is limited or binding by this constraint that I will use here in order to validate that the values I am producing fulfill this regex. So the field that I am producing here fulfill the regex. If in some moment I broke this contract, let's say that I generate the numbers in this way, then the contract will not be validated. I can execute only this method. Since it's a JUnit test, I can run it and I can test it individually. So let's go to see what happens if I generate an account that in theory doesn't match the regex. Just the second is building. So the test is broken. Why is broken? Well, I'm expecting this value to match the regex. As you can see, it doesn't never match because it should start by 0 and I have here a 1. If I generate the right value, okay, let's say 0, 0, 4, 2 should match, and I run again the test, just a bit, it's compiling again. The test is correct. So now I don't have any logic in behind, but I am building a system that I can start implementing and testing that my logic and my data is generated as should be. Okay, now I am testing one part of the contract. We have another part that is when I am subscribing and receiving messages. Okay, so let's go down a bit. We have here two validating functions: the store environment validation and the store account validation. Okay, so those two functions here just run the code for testing the consuming message. I am creating a message here, and you can see this JSON thing is created automatically in the generated code, and this JSON is sent to this class that will create the message. This message will be sent through the binding that will get the message and send it into the application. Okay, and then we will just call the store information validation. This is method here that will validate that the data is injected and is correct. So what I do here, I just capture the value of the service that is saving the data. We got the value, and then we validate that this value is not null. So we actually have something that this value is an instant of the back movement entity that it should be, because it's the thing that I am using in my service. And I just extracting a couple of values, okay, and testing that those values are correct. But where those values come from? Those values come from the data I am sending here, okay? So I have the one for the ID, the one for the ID, the account number 32, the account number 0032, and the movement type is a deposit, the movement type is a deposit. But where those values were generated? Well, those values were generated in the back movement YAML that we have here. As you can see, the example is a 001. This case is it's a number. If I just specify as a string, sorry, then I will got a 001. But because I just put here a number, is the same writing in that way or just writing in that way, no problem. What about the account number? The account number is a string and should fulfill this pattern, the pattern that we have here. About the movement is a string, but it's an enum with this specific value. That is the same thing that they can see right here, okay? So based on the examples that I have, I am generating a test that will inject these staff values into the system, and I'm catching them here, and I will validate that these values are the one that I am expecting. Because I catch it in the service, let's say that you have some specific logic that has some incremental validation, mutation, or changing the data, and I just intercept these values in my repositories on my infrastructure ledger just before sending to the database, and I can test that this logic and this data, it's working okay. What happens if I don't have data specified here? Well, as you can see here for the dates and also for the bank account, I don't specify any example. So it's just like I don't care about the data at the moment. So the data is generated at random. So we detect that is a number, so we generate a number. It is a date that we just generate random dates. It's a name because we generate whatever thing that can fulfill here. If in any moment I just decided to produce an example here, let's say some business manager came and say that we need to test it for this specific account and with this specific name, because it came from somewhere, and suddenly someone decided to modify this thing in order to match this specific account number. So we change this value here, and we change this value here. So I just need to regenerate my project. So clean and install again. The code will be generated. The stuff will be regenerated. The contract test will be regenerated based on the new premises. And of course, because this thing has changed in the API, that is something that we should change before just change the code, then the test should work, hopefully. Okay, now the tests are broken because something has changed. In the meter, I am expecting to receive something that fulfill the regex, but I have a 0042. So it's not a hard change, so I just need to validate and change something like that, maybe. And something like that, and see if that thing works well. let's say that these values were generated by some specific logic. So the logic has changed, so I can detect these changes just before my code goes into the first staging or pre-production or just also in production. That allows us to handle all the changes. See, maybe it's not absolutely right. 0, 4, okay, so it's not 4, it's a 7, 0, 0, 4, 7, 7, 7. Let's gonna hurry up a bit because we are a bit short of time. Just run the test here in order to check it. You can see the regex has been also updated in the test. Running here, we just skip all the building process and so I just can also debug the code here. Let's say I want to put a breakpoint and fix it. Well, it supposedly should work, but now I broken the things, so I just need to wait until the business manager decides something different here, or just start working around to see why it's complaining. Looks like I just forgot how to write a proper regex. So the thing is that I just demonstrate that I'm not a master of regex, so I just can go back here. It does some problem, and here I can just go back here, and here I can just go back. Oh, no, so back. And I can rebuild all the things. And hopefully all goes well with flying colors. So this is how the proper ApiFirst and content generation works. So showtime is over. Thank you for listening to me. So if you have any question, please don't doubt in just asking me, or you can contact me through Twitter at jmachineiras, or just send me an email, or just please visit our GitHub repository so you can find there all our tools and you can open issues or questions. So feel free to come to us. So thank you very much. Thank you for hosting me. Bye bye.